Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn, in this session we are going to create a self-driving car game with the help of pygame. Okay, and then we are going to control our self-driving car direction like right and left direction with the help of real-time face tracking points. Okay, so before we move to our practical, friends, if you learn something from our videos, please consider to subscribe our channel. Okay friends, thank you so much, and let's get started. So friends, as I mentioned, we are going to create here a self-driving car in virtual world, the game, with the help of pygame on our Raspbian Buster legacy version, 32-bit version. Okay, then what we are going to do, we are going to control our self-driving car left and right direction with the help of real-time face points. We are going to use here our CV zone module for face tracking, and then we are going to use the face points for controlling our self-driving car left and right direction. Okay, I hope you get the idea what we are going to do. So first we are going to create here our game. So for that I have created here a repository. I will mention the link. You need to simply copy and paste the link inside your browser, then go to the code, copy the link from here, and we are going to clone our repository, and then we are going to change the owner. Okay, so sudo git clone and paste the link and just hit enter. It will clone the repository. Then sudo chown space -R, pi is the user, colon, pi is the group, and our repository name, which is the self-driving car. That's it. We have done with the downloading, and we have done with the changing owner. Okay, so now if I open the file manager, here it is what our self-driving car folder, and inside that we have our resources for our game. So we have our car image, we have our track image. Okay, so this is what our track image. As you can see, the track image is basically 1200. This is the width and this is the height. So we are going to create the display for our image. Our track image is basically 1200 and 400. This is the width and this is the height. Okay, so simply first we need to, let me just close the image, and first we need to install our pygame package. So run the command sudo pip3 install pygame and just hit enter. It will install the pygame on our Buster legacy version, which I have already installed. As you can see, the requirement is already satisfied. So now let's just get started, and we are going to create here our code for our game. So open the Thony Python IDE, and we are going to create our file inside the same folder, self-driving car, because we have our resources in self-driving car. So untitled, simply click on save, pi self-driving car, and let's say drivecar.py. You can mention any name. I have created here a drivecar.py. This is what our Python file name. Simple. So we have our package installed. Now first we need to import our package. Import package, import pygame. That's it. Now what we want to do, we want to first initialize our game. So pygame dot init, like this way, pygame dot init, and then as I mentioned, we need to create here our display, and our track image size is basically 1200 and 400. So 1200 is the width of our track image, and 400 is basically height of our track image. So we need to create here a display same as our track image width and height. So 1200 and 400 is the width and height for our display. So window is just a variable. Window is equal to pygame dot display dot set mode, and then we need to mention here the width and the height. So width is 1200 and height is 400. Okay, so now we are going to create here a function. Okay, and inside that function we are going to set our conditions for our game. So def game, this is what our function name, game, and then we have our display. So now simply what we are going to do, we are going to update our display. Simple. So pygame dot display dot update. So pygame dot display dot update. That's it. So now what we are going to do, we need to create here a while loop. So while true, and then we need to call our function. The function name is game. That's it. If I save the code, if I run the code, and as you can see, this is what our display. 1200 width and 400 is the height. That's it. Now we need to load our images. So first we are going to load our track image. So track is just a variable, and this track is basically our track image. So pygame dot image, and as I mentioned, we are going to load our image, so we need to mention load. So pygame dot image dot load, and we are going to load our track image. So track dot png. Okay, that's it. Now same way we are going to load our car image. So let's just load our car image. So car is equal to same way pygame dot image dot load. Okay, and our car image name is mycar.png. So mycar.png. That's it. Now the method is basically where we are going to load our image. We are going to load our image on the window, because this window is our display. So we need to call our window variable over here, and then window dot build. Okay, window dot build, and then first we are going to build our track. So track, and then we need to mention the XY coordinates. So 0 0, because we want to create the track as a full screen, means as a full screen of our display. So for that we need to mention 0 for X and 0 for the Y. Okay, so 0 0, that's it. And then we need to mention our car. So window dot same method, window dot build, and then we need to mention the car. And for our car, let's say X is 100 and Y is also 100. That's it. So let's just save the code. If I start the code, there is a problem, I think. What is the problem? Track. Okay, the spelling mistake, track, that's it, the silly mistake. So let's just get start again. As you can see, we have our track and we have our car. Okay, but our car is really large, so we need to set the scale for our car. Okay, so for that we are going to use pygame.transform. Okay, pygame.transform, and then we are going to mention the scale. So simple, let's say car is equal to pygame.transform, and we are going to say, as I mentioned, scale. Pygame.transform.scale, it will set the scale for our car image. So we need to mention our car variable, because this car variable, here it is, this car variable is our car image. So we need to mention the car, and then we need to set here scale. So 3060 is enough. Okay, so let's just save the code. If I start the code, and as you can see, now we have our car, but we have our car not on the road. Our car is off the track. Also we need to set our car at the start line, but first we need to set our car on the track. So remember one thing, friends, this is what our X. Okay, this is what our X. Okay, and this is what our Y. So this is what our width, and this is what our height. So width is basically our X and height is basically our Y. Simple. So it start from 0 to 1200 and it start from 0 to 400. Okay, so what is the problem is basically our car is not on the track. So this is basically X. Okay, this is the X. So we need to increase our X value for our car, then our car will be on our track. So right now our X coordinates for car is 100. So as I mentioned, we need to increase our car X coordinate, then our car will become on the track, because this is the X. Okay, so we need to change our X for our car. So let's say 155. If I save the code, if I run the code, and as you can see our car is now on the track. Okay, now we need to set our car at the start line. So this is the y. Okay, this is the y coordinates. So simply we need to change the y coordinates for our car. So as I mentioned, it start from the 0 and it's come at the 400 because our height is 400. Okay, so if the end is 400, that then we can say here it may be 300. Okay, so we can say our y coordinates for car is 300. Okay, so let's just change the y coordinates. Let's say 300. Save the code. If I run the code, and as you can see, perfect, 300. Now our car is at the start line. Simple. So now we have done with our car. Now what we are going to do? Now we need to create here our camera, because our car is a self-driving car. So we want to create here a self-driving car. So we need to put the camera on our car. For that, first we need to create the camera set point, and then we will get the camera X point and camera Y point with the help of car X and car Y. Why? Because where we want to put our camera, we want to set our camera on the car. So camera X and camera Y point is basically our car X and car Y, because whenever our car is moved, the same way our camera will be moved, because our camera on the car. So we need to create here camera X and camera Y point same as our car X and car Y. Okay, so first we need to mention here camera X set, camera Y set, and then we are going to create camera X and camera Y. Simple. So now what we are going to do here, first we are going to say, first what we are going to do before we set our camera, we need to create here a two variable, because we need to mention these numbers. Okay, so we are going to set here a car X and car Y, and this car X and car Y will be basically we are going to set our coordinates, and simply we are going to call the variables. We are not going to set here the numbers. So simply what we are going to do, we are going to create here car X is equal to our 155 and car Y is equal to 300. Same numbers, okay, same points. Simply we just create here a variable, and this car X and car Y is now our coordinates. Simple. So here instead of number we are going to simply say car X and car Y. Okay, so same effect. We only mention the variables. Okay, car X and car Y. As you can see, same effect. Simple. So now as I mentioned, we need to create first cam X set, and right now it's a 0, and cam Y set, right now it's also 0. Okay, so cam X set, cam Y set is equal to 0. Why cam X set? Because when our car will move, okay, will move on the track, the car basically comes here, it will make the turn, it will make the right turn. When the car will make the right turn, okay, because this is the virtual world, our camera not move with the car. So we need to set our camera again and again same direction, because in a real world, whenever our car move, our camera will move at the same way, we can say, because our camera is on the car. But in virtual world, if the car goes here and car make the right turn, our camera will not move with the car. So we need to set our camera as again same direction. For that we need to create here a cam X set point and cam Y set point. I hope you all clear. Okay, so simple. So now we can say cam X, because we need to set our camera. So cam X is equal to, as I mentioned, cam X is basically our car X plus our camera X set. Okay, and same way cam Y is equal to our car Y plus cam Y and the set. That's it. So cam x and cam y is equal to car y set, car x, cam y x set. Now we have our cam x point and cam y point. So simply we are going to create here a circle, and that circle basically represent our camera. Simple. So we are going to create here a circle. So pygame dot draw. What we want to draw? We want to draw the circle. Okay. So then where we want to draw the circle? We want to draw the circle on our window, because the window is our display. So window, then the color, so R, G and B. So we are going to set the color for our circle is blue. So we need to mention the last value 255, and another 2 will become a 0, because we want to set the blue color for our circle. Then we need to mention cam x and the cam y. Okay, cam x and cam y. Then what we want to mention? We want to mention the radius and the thickness. That's it. Now if I save the code, if I run the code, and as you can see, this is the circle, and this circle is basically our camera. But as I mentioned, we need to set our camera on the car, but still our camera is not on the car. So what we are going to do? We are going to simply add some points for setting our camera on the car. Simple. So let's say we can say plus 15 is enough, plus 15 is also y, for the y. Okay, so now if I start the code, and as you can see, now we have our camera perfectly set on the car. That's it, friends. We have set our car on the track. We have set car at the start line. Also we have our smart camera on the car. Okay, that's it. Now we are going to move forward, and we need to create here our action. So what is the action? As I mentioned, the action is going up. Okay, going up, then make right. Okay, so now what we want to do? We want to set our car somehow it's go up. Okay, so how to set the action for up? Simple. What we are going to do? As I mentioned, this is the y. Okay, this is the y. So if we goes, the y value is basically start from the 0. So 0, and it's come at the 400. So if we want to set our car for up action, okay, for up action, so simply what we can say, up is basically the minus value. So if it is 400, then it's go 390, 380, 370, then it's go at the 1. We can say we are going to minus the y value. Okay, so we can say if we want to move our car at the up direction, so we can say we can create here car y is equal to car y minus how many points we want to minus here. Okay, so let me set like this way. Okay, here we have our function. We are going to update our function with the while loop. So simply after updating our function, we can say car y is equal to, as I mentioned, car y, how many points we want to minus. So let's say minus 5. Okay, so if I save the code, if I run the code, as you can see, our car is going up, and it's crashed. Basically we create here only how our car goes up, but somehow we need to set here where we want to car stop. So we can see here we have our track, and our up track is end at here, and after that there is no track. So basically our track is in the white color. So white color is basically start with 255. So somehow we need to read our track coordinates, our track color coordinates. For that we have here our camera, and our camera is basically read the track coordinates. Okay, so simple. First we want to create here a direction. So this is the direction when our game start. What is the direction for our car? Simple. Our direction for car is basically up. So by default the direction is up. So simply we are going to create here another variable which is the direction. Direction is basically up. When we start our game, the car direction is up, it's going up on the track. Simple. Now friends, as I mentioned, somehow we need to read the track coordinates, means our track white color coordinates. For that we need here a camera focal distance. So we can say here another variable, we need to create here focal dist, and by default the focal distance we can set 25. Okay, now as I mentioned, if I start the code again, then we will get the better idea. Now as I mentioned friends, our car is going up. Okay, so friends, what is the condition? The condition we are going to create here, if the car is going up, okay, if the car is going up and our camera is reading the white color coordinates, means the 255. Okay, so if there is no 255 points again, then our car will be stopped. So this is the condition. Okay, so first, as I mentioned, we need to create here, somehow we need to read up px, means the up road track pixel with the help of our camera. I hope you all clear. Okay, simply how we can do this, simply we need to create here up pixel. Okay, so up px is basically our up road pixels. Okay, so up px is equal to window dot get at, as you can see, window dot get underscore at, and then inside that we need to mention how we can get our white road coordinates. Simple, that's why we have our camera. So we need to set here camera x. Our camera is basically camera x point and camera y point. So camera x and the camera y. That's it, simple. Camera x and camera y is represent our camera, because we create here a circle and that circle is basically our camera x and camera y. So if we want to read the coordinates of our white color road, so we need to set the camera x and camera y. Simple. Then we need to add here our focal distance. Not basically add, what we are going to do, as I mentioned, we need to minus our focal distance. Why? Why minus? Because we are going to up. So when we goes up, the y direction is basically we are going to minus. So it basically start from 400 and it goes at the 0. So what we are going to do, 400, 399, then 380, then is going, basically we are going to minus the points, then we will get the coordinates. Simple. So if I start the code, and here we are going to print up px. Okay, so if I save the code, if I run the code, now here it is, as you can see, 255, 255, and then when the track is over, the coordinates is 46, means we don't have 255 coordinates, means we don't have the road. Okay, so simply we can say, as you can see, the 2555, and after that it's go at the 2323. It means there is no road, there is no white pixel on our track. Okay, so simple, what we can say, we can create here a condition. Okay, so up px, I hope you are all clear how we can read the track white pixel with the help of our camera. And as I mentioned, simply we need to minus the focal distance, because we are going to up. If we want to read the up pixels, simply we need to minus the pixels. Okay, so 400, 399, then it's go on. Simply we are going to minus the coordinates, then we will get the pixel. Simple. So for that I have created here a up pixel window dot get underscore at cam x cam y minus our focal distance. I hope you clear. Now simple, here we need to create return, because we need to call our up pixel inside the while true loop. So simply we need to call here a return, and then we need to mention up px. Then we can call here our up px. So up px is equal to our game. Okay, simple. Now what we can say, as I said, we need to create here a condition for going up direction. So what we can say, if what is the direction? The direction is by default up, because when we start our game, our car is going up direction. So simply we can say if direction is equal to up, if direction is equal to up, and what is the condition? If the direction is equal to up and our up pixel is 255, if the direction is equal to up and the up pixel is equal to 255, then our car will be move at up, otherwise it will be stop. Simple. Also friends, here we need only the first value, only first value. So this is the first value is 255, so we need to mention the index value. So index value is basically 0. We only need here a first point, we don't want the four other 3 points, so we need to mention here the index value of our first point. So of course the index value is 0. It starts like this way, 0, 1, 2 and 3. So we need to mention 0. Okay, so if I start the code, if I run the code, it's going up and it stop, because we set here a condition. If the direction is up and only the up pixel is 255, then our car will be move up direction, otherwise it will be stop. I hope you all clear, because our camera is reading the pixel, and when it reach at the end at our track, there is no more 255, means there is no more white track, white pixel, that's why it's stop. That's it. I hope you clear. Now what we want to do, now we want to make our car as a turn direction. So we have again our camera. So when we reach at the end of our track in up direction, the camera will be see that we have the white pixel at the right direction. At the right direction we have the white pixels. Again we need to set our camera to read the right pixel. So same condition, same way we can create here up px. So now we can say the right px. So copy it, the code, and just paste. Okay, and this time what we are going to do, we are going to change the up px with the right px, and as I mentioned, let me first just uncomment, because we need to explain the idea for right px. Save the code. If I run the code, so friends, as I mentioned, what we want to do here, we want to set our camera to read the right px. Okay, so here what we are going to do, we are going basically up direction. So here what we are going to do, we are going to go like this direction, the right direction. So what we are going to mention here, this is the x point. Okay, so it starts from 0 to it ends at 1200. Okay, 0 to 1200. So what we are going to do here, we are going to add the points for 1200. Let's say 0, 1, 2, 3, 4, 5, 6, 7, and it goes and it end at the 1200. So basically we are going to plus the points for reaching at the end, means reaching at the 1200. Okay, here we start from the 400 and we are going to reach at the 0. So we are going to basically the minus the points. That's why we are going to minus the cam y with minus focal distance. So here we are going to add the points, because we need to go with basically start at the 0 and goes at the 1200. So we are going to add the points for reaching at the 1200. So we can say we need to add here camera x with the focal distance. So here we can say this is what our condition. So right px window dot get at camera x plus focal distance, and now we don't want to minus the focal distance from camera y. We want to add the focal distance, then we will get the right side pixel. right px. Okay, so if I save the code, if I run the code, you will see at the end we have 255. Let me start again, then you will get the idea. Watch the shell. Okay, here it is, as you can see, 4646, and when our car reach at the end at upside, then as you can see we have again started the 255 at the right px point. So it means when the car reach at the end, we have the white pixel at our right. It means we have the road at the right side. Okay, so I hope you all clear why we plus the focal distance, because we are going to go like this way. As I mentioned again, 0 to 1200. Basically we are going to add the points, we are going to plus the points for reaching at the 1200. Okay, that's why we plus the focal distance with the camera X. Now we have our right px. Simple, we know that we have road at the right side. Simply we are going to create the condition. So what is the condition? Let's create the condition here again. So the condition is what? If we have the right pixels, means we have the right road. So what is the direction? So now the direction is the right. For that, first we need to set the direction. So for that we need to create here another condition. If the direction is up, okay, because right now what is the direction? The direction is up, but there is no up pixel. Okay, so we can say like this way: if the direction is up and the up pixel, the up px is not is equal to 255, because our road is end at the up point, up direction. So we need to set if the direction is up and there is no more 255 pixels. So we can say like this way: if direction is up and up px is not is equal to 255, but and we have right pixel, because we set here we have the right pixel. So we can say and right px is equal to 255. Okay, so we have up direction, but there is no up pixel. So up px 255 is not 255, but the right px is 255. Then we can create the direction is equal to right. Then we can say we need to turn at right. Okay, so this is what the condition. Okay, and here in return, because we need to call our right px in the while loop, so we need to mention return right px. I hope you all clear, friends. Okay, so now we have our direction. We know the direction is right. Now simply here we can let me make like this way. We can set elif the direction is equal to, what is the direction? The right direction which we create the right. So we need to set here direction right, and of course the right px is equal to 255, because we know that we have the road at the right side. So right side the pixel is 255. Okay, as you can see the pixel is 255. Then what we want to do, car x is equal to car x plus 5, because we are going to add the points for reaching at the 1200, which is the end of our width. So we are going to start with 0 1 2 3 4. This is what we are going to adding the points. So we need to say here car x is equal to car x plus 5. So if I save the code, if I run the code, right px, okay, there is something problem. What is the problem? Right px, okay. Also we need to call here our variable. So I forgot to mention, that's why it says the right px is not defined. So we need to call here our right px, because as I mentioned we need to call our right px inside the while loop. Okay, then it will work. That's why we mention inside the return right px. Simply save the code. If I run the code, it's go up, and as you can see it's going at the x side, because we mentioned the when it reach at the end and there is the right pixels, so car will be goes at the right side, and we adding the points with plus points, plus 5 points. As you can see, car x is equal to car x plus 5. Okay, so we successfully go at the right, but our direction is not changed. Our direction is not changed, so somehow we need to change the direction of our car. Also we need to set the camera direction. Okay, so first we are going to change the car direction. So when our car reach at here, okay, we can say we need to rotate our car. So we are going to create here another condition inside here. If the direction is right, we can say car is equal to, we are going to use pygame dot transform, pygame dot transform. We are going to use the rotate. Okay, we are going to rotate. What we want to rotate? We want to rotate the car, and we want to rotate the car as a clockwise. So for that, minus 90. So car pygame dot transform dot rotate. What we want to rotate? Car, and the 90. This is the action for clockwise. Okay, so if I save the code, if I run the code, car is going up, and as you can see, it's rotate, it's perfectly turned. Now we are ready to go forward, or we can say go right. Okay, but where is our camera? As I mentioned, this is not the real world, this is the virtual world. So for that, every time we make turn, we make a right or a left, we need to set our camera again at our same position. For that, we create here the cam set. As you can see, for that we create here a cam set, because we need to set always our camera at same position. Simple. So here, this is what our camera Y. Okay, this is what our camera Y, and this is what our camera X. Okay, so what we can say here, let me first set the condition. So here we can say cam X set. What we are going to do, we are going to plus this 15 plus 15, so we are going to say 30. So if I save the code, if I run the code, it's go up, and as you can see, camera is now on the perfect direction, or we can say the camera is now perfectly set on the same direction where we start. Okay, so if I again comment, I need to explain here, then you will get idea. So this is what the Y, this is what the Y for camera, and here the camera is right now on the Y side, because we start at the Y. Okay, the camera is same direction, the Y, so we need to set our camera again at the X direction. So for that, we are going to add the X points. Okay, so for that, we need to mention the camera X set is basically the 15 for plus 15, then it will come at the same position. Okay, this is the Y and this is the X. For that, we mention the camera X set is basically 15 plus 15, 30. I hope you clear. So we reach at the here. Now we need to go down. Again, same condition. We can say here, if the direction is right, but there is no more white pixel for right side, but we have the downside, and downside we have again 255 pixels. So same condition we are going to create here. We can say we need to simply copy this condition, copy it and just paste, and this time we are going to say the down px. So down px, down px window dot get at, and because we are going to down here, so what basically we are going to do here, let me explain again. If I start the code, here we are going to up. So this is what basically we are going to do here. This is what the Y. okay, and when we want to go up, we are going to minus our points, and this is again y. So right now we are going to go down, so we are going to adding the points because 0 1 2 3, okay, and we are going to reach at the 400. So we are going to basically go at the down, means we are going to adding the points. So what we are going to say, we need here somehow we need to track the white pixel at the downside. So we can say camera y plus the focal distance, because we are going to add the points. So we can say camera x plus focal distance, then we will get the down pixels. Simple. So we can say here, where is our condition? This is what our condition, down px and the camera x plus remove, and we are going to add camera y, cam y plus the focal distance, then we will get the down pixel, okay, down px of our track, of our road. So we need to check over here on in the shell, and as you can see, we are at the end at the right side, and as you can see the downside, this is what our downside, we have 255. Again we have the downside track. Simple. I hope you all clear why we are going to plus the camera y plus focal distance, because we are going to down, so we are going to basically adding the points 0 1 2 3. When we want to go up at the y side, we are going to minus the points, because this is the 400. If you want to reach as the 0, we need to simply minus the points. If you want to go down, so we are going to adding the points. Simple. This is the funda. Simple. So we have down px, so inside the return also we need to mention down px, and here also we need to create the another variable down px. Okay, now simply we can create here a condition. So here we can say, first we need to set the direction. Okay, so we have set here a right direction, okay, the right direction. Now we need to set the down direction. So for that, elif same way direction, if the direction right now the direction is the right, so direction is equal to right, direction is the right, and no more white pixel at the right. So right px, okay, right px is not is equal to 255, and we have the down px, so we can say down px is equal to 255, then the direction of our car is basically down. Okay, so if the direction is the right, if the direction is the right and there is no more right pixel, so we create no more right pixel, means right pixel is not is equal to 255, but I forgot to mention here and. So and the down px is 255, then the direction is down. Then here we can say if the direction is equal to down and the down px is equal to 255, then we can say we need to simply add the y points inside the car y. Simple. So car y, because we are going to down, so we are going to adding the points. So car y is equal to car y plus 5 plus 5. Okay, if I save the code, if I run the code, and as you can see our car is going down, but again we need to rotate our car. Okay, so simple. Here we are going to say inside the down, we can say here we need to rotate the car, so we need to rotate the car again clockwise. So simply same condition, car is equal to pygame dot transform dot rotate and car minus 90, because we want to rotate the car as a clockwise. So simply we are going to start our code. So friends, here it is. As you can see, our car is perfectly rotate and it goes down, but our car is not on the track. So this is the x coordinates. Okay, this is the x value. So we need to set our car at the x points. Basically we need to add our car x with some points, then our car will be come on the track. Because let me show you here, then you will get better idea. So I need to just comment this side here, then our car will be only rotate, it will not go down, then you will get better idea. Okay, so it's going up, right, and it's rotate. As you can see, it's rotate, but it's not on the track. So this is the x. Okay, this is our x. So we need to add the car x point, then it will come on the track, because this is the x. Simple. So we need to create here car x is equal to our previous car x plus 15 plus 15 again, same 30. Okay, if I save the code, if I run the code, because we add some more pixels inside our car x, so now we can see our car is on the track, because this is the x, this is the x, and this is the y. So when we rotate our car is somehow at the minus level at the car x. So simply we need to add some points, then our car again come on the track, because this is the virtual world, friends. Okay, this is the virtual world, so there is lot of conditions. So simply we need to add the plus points. So we have add the plus points at the car x, and then our car is now on the track. Now what is next condition? So next condition, we want to set our camera also on our car. Okay, so here we increase the camera x set for right direction. So we need to set our camera x set 0 for down, and then we need to add the y camera set with 30. Okay, so simply we are going to set here a reverse condition. So let's say first, because we add here a camera x set with 30, so first we need to set the camera x set is equal to 0 for going down. Okay, so cam x set is equal to 0, and then we are going to increase the y set. So camera y set is equal to 30, because when we go right, we add the camera x set is equal to 30. First we need to mention camera x set is equal to 0 for the down direction, and then we need to add the camera y set is equal to 30. Simple. So if I save the code, if I run the code, it's go up, right, and as you can see, we are ready to go down, and our car is also on the track, our camera is also on the car. Now we are ready, and let me just uncomment our condition from here, then our car will be go down. Okay, save the code. If I run the code, it's going up, it's make right, turn and down. That's it. I hope you all clear. Now friends, what we are going to do, we have done with creating the conditions, means we have completed the directions. We have right direction, then we have down direction. Okay, so we have now the direction is, as you can see, the up, right and down. So we have, so here again and again we have the same direction. So now there is no more to create up px, right px and down px condition again and again. So we have done with creating the condition. Now simply what we are going to do, we are going to add here this condition, the directions. We need here the direction. So we have right direction, we have down direction. Now again we need to create the down direction with next condition. So what is the next condition? It's come here. Okay, so what is the next condition? Next condition is, if the direction is down but there is no more right, sorry, not right, there is no more down pixel, means there is no more white pixel at our down track. So here it is, as you can see, the track is over, so there is no more 255 pixel at the down track, but we have the right side road, means we have right pixel at 255. Okay, so simply we can create here another new direction. So copy this one, and then we are going to say here, just paste, and we need to check the level. Okay, just like this way. Okay, so we have set the line. So what is the direction? So direction is down, because we are right now at the down direction, down, and the down pixel is not more 255. So down is not is equal to 255, but we have the right pixel 255. Okay, so right px 255. So simply we can create the direction right, because we need to go at the right side. Okay, so let's just remove all these things, because we are going to set all these things at the new way. And what is the rotate condition? So rotate, we want to rotate our car at the anti-clockwise. Okay, so simply if I save the code, if I run the code, remember one thing, because we already set the right direction, so car will be go like this way, because we have already set the right direction here. When the right direction is there, as you can see, when the direction is right, it will add the points with car X. That's why our car is moving right, because we already set the condition. The same track is there. Okay, as you can see, it's going right. But again, our car is not on the track. Also our camera, what we are going to do here, we can say after right, here we add the car X. So now simply we need to add the car Y. So car Y is equal to car Y plus 30. Car Y plus 30. Save the code and run the code. It's coming, and as you can see, our car is on the track, but again our camera is not on the track. So again we need to reverse the condition. Here we set the x0, so we need to set cam x set is equal to 30 and cam y set is equal to 0. The reverse the condition, cam x set 0, so here we need to set cam x set 30 and cam y set 30, so here we need to set the cam y set is equal to 0. So if I save the code, if I run the code, it's going up like this way, and it's reached at the end. Okay, now again there is no right pixel, there is no white pixel at the right, but we have up pixel. So simply again we need to copy this condition, copy it, and let's just paste, and we need to check the level. I hope it's in line. Okay, it's in line. So now what is the direction? Direction is the right, so we can say right, but the right pixel is not is equal to 255, but we have here up pixel. Again we need to delete all these things, because we need to set all these things new way, and simply we want to rotate the car again at anti-clockwise. So if I save the code, if I run the code, it's coming, and as you can see, here it is, it's collapsed, because there is, oh, I forget to mention up here. I have set the right, so we need to set here up. Okay, it's going up, right, down, right, and as you can see, it's going up, but right now again car is not on the track. Also it's completed our another track, because the same track is we are going to use again. Okay, that's why it's reached at the end. But here as you can see, our car is not on the track, because when it's go up here, our car is not on the track. So we need to set our car on the track for this condition, when the direction is right, but there is no right pixel, but up pixel is 255. So we create the direction is up, because we want to go at the upside, because we have the up pixel, means we have the white pixel at the up direction. So we rotate our car right way, the anti-clockwise. So simply we can say here, so here we mention car y, so here we need to mention car x is equal to car x plus 13. Okay, and then we need to simply mention here cam x is equal to 0. So cam x set, because we mention here cam x set is equal to 30, so here we need to cam x set is equal to 0. That's it. If I save the code, if I run the code, it is going up, right? Now as you can see, it's on the track, camera is also there, and it's completed our full track because the same track is here. Okay, so we reach at the end and then our game is over. So we have completed our game part. We have successfully created a self-driving car in the virtual world with the help of pygame. Now we need to track our face with the help of CV Zone. For that, first you need to install OpenCV, TensorFlow Lite, MediaPipe and the CV Zone on Raspbian Buster legacy version. I have already created a video how to install OpenCV, TensorFlow Lite and MediaPipe. I will mention the video link. Watch video and first install this basic package. Now we are going to first install the CV Zone package because I have already installed the TensorFlow Lite, MediaPipe and the OpenCV. So sudo pip3 install CV Zone and just hit enter. It will install the CV Zone on our Raspbian Buster. Okay, as you can see I have already installed it. That's it. Now what we want to do, we want to call our CV Zone package. So we can say from CV Zone dot F capital then D capital CV Zone dot face detection module. Okay, so face detection module M capital. Okay, so from CV Zone face detection module we are going to import face detector. So import again F capital D capital. That's it. From CV Zone dot face detection module import face detector. Now we need to call our module over here, so we can create here a variable. So variable is detector is equal to face detector. Okay, detector is equal to our module which is the face detector. That's it. Now we need our camera USB webcam which I have connected with the Raspberry Pi 4. So cap is equal to cv2 dot video capture and index is 0. Okay, cap is equal to cv2 dot video capture, index is 0. Simple. Now here inside the while loop we need to call our camera. So we can say rate frame is equal to cap dot read. Okay, cap dot read, then frame is equal to cv2 dot, we need to resize our frame, so we can say cv2 dot resize method. Okay, and then we need to resize our frame and we need to mention the width and height. That's it. Then we need to flip the frame, so we can say again frame is equal to cv2 dot flip. Inside that we need to mention frame and the one for flipping the frame. That's it. So we are basically reading the camera. So cap dot read, resize the frame, flip the frame. Now where we end our all conditions for our pygame, after that we need to show our frame. So cv2 dot imshow, inside that first we need to create the window name. So we can say frame is our window name and then we need to call our frame. Okay, then we want to mention the wait key, so we can say if cv2 dot wait key like this way. If we press escape key from the keyboard, it will break the loop and it will release our cap dot release and cv2 dot destroy all windows. Okay, cv2 dot destroy all windows. Okay, that's it. So if I save the code, it will start our camera and it will show our frame. Okay, so import CV2. Okay, so we forget to mention here our main module, which is the CV2. We mentioned the CV zone, but we forget to mention CV2. So simply mention the import CV2 because we want to show the frame. So simply we need here a CV2 module. Okay, so friends, as you can see, this is what our game, and also we have our frame. Okay, so we are ready. Now we need to simply call our face detector function. So we have our variable which is detector, which represent our function. So simply we are going to create here a new function for face. So we can say def face, okay, like this way, and inside that our object is our image. Okay, then we need here our image, then b box, okay, is equal to our detector, which represent our face detector module. So we can say img b boxes, and detector, what we want to detect, we want to detect the face, means we want to find the face. So detector dot find, f capital, like this way, detector dot find faces, and we are going to pass here our frame, not frame, our object, which is the img. Img is equal to b box detector dot find faces, and it will, we need to set here our object, which is the image. Okay, that's it. Now if we print b box, then we will get the information. Okay, and of course we have our function, so we need to call our function inside the while loop. So after where we call our game function, after that we can say here we need to call our face function, and inside that we need to pass our frame. It will track our face. Okay, so if I start the code, and as you can see, it's tracking my face. There is a rectangle, and here it is. As you can see, we have the information. Okay, so we can use this information for controlling our virtual world self-driving car right and left action direction, we can say. Okay, so what is the information? We have here b box and the id 0, and here center. Center means this is what our circle, the center point of our face. So after center we have the points x and y for our center points, or we can say the circle. So this is the x and this is the y. So we need here only x point. So we need to create here like this way. We can say, where is our function? We need to go inside the face function. So here we can say, we know that what we print. So right now there is no need of printing b boxes. So we can say here, if b box is there, then we can create here a variable name called center, and inside that we can say b box. Okay, b box, and this 0, as you can see the id after id we have 0, so we can say here 0, and then we need here a center. Okay, so simply we can say like this way, center. So if we print here a center, if we print the center, if we'll save the code, if I run the code, as you can see, we have now 1 minute. We need to stop our game print, then we will get the idea. So up px and right px, down px, I am just going to comment all these things. Now we will get the idea about the x and y coordinates of the center point of our face. Okay, so it start our game. We have our frame ready, and here it is. As you can see, as I mentioned, we have now only 2 points. So this one is the x and this one is the y for our center point of the face. Okay, so simple. Now as I mentioned, we are going to use here our x. So we can say this one is the first value, so 0 index. simply we can say here like this way, where is our function? Here it is what our function. So we know what we have inside the center. So we can simply say cx is equal to int. Okay, cx is equal to int, not int basically. 1 minute, we want to first need here our first point. So we can say cx is basically center, and the first value, which is the x, so we need to mention the 0, because this one is the 0 and this one is the 1. Okay, so cx is equal to center 0. So if I print cx, now it will print only this value, the x value. Okay, so it will start our code. As you can see, now we have only one value, the first value, which is our x value. Okay, so we know that we have cx. Now what we are going to do, we can say here a is equal to, okay, a is equal to int cx divided by 60. A is equal to int cx divided by 60. So if we print here a, okay, so if I start the code, so now inside the shell, as you can see, right now my face is as center and the value is 5. So if I go at the right, as you can see, it's increasing the value, it's greater than 5. Okay, it's now 9. Again, if I come at the center, it's 5. If I go at the left, it's less than 5. So simply we can create here action for our car. If we go at the left, then our number is basically less than 5. So if we go at the right, our number is greater than 5. So simply we can create here a condition. If our car is moving at the right and our face is also go at the right, then we will have the number is basically greater than 5. So we can simply create the condition. Okay, so we know we have here the point. So simply what we are going to do, we can say return and a. Okay, and then we need to call our a over here. Where is our while loop? Here, this is what our face function. So simply we can say a is equal to face and the frame. Now we have our a value inside the while loop. So simply where we have our game condition here also. As you can see, if the direction is up and up px is 255, we need to create here a condition, or we can say we need to mention our a here. So we know that if up px is not is equal to 255 but there is right px, then our car will be move at the right clockwise, as we mentioned here. As you can see, so we have what we are going to do, we need to add here our face condition now. So we are going to simply remove the right px, and we can say if up px is not is equal to 255, then of course the direction is what, the right. So simply we need to say here, when we go at the right using our face, the number is basically greater than 5. So we can say a is greater than 5, then only our car will move left, or not left, basically right. Okay, so if I save the code, if I run the code, as you can see, our face is there and our car is going up, but here it is stopped. Why? Because we mentioned if our face at the right side means it's greater than 5, then only our car will be go at the right direction. So if I go at the right, as you can see, then it's only going here, here, here. But after that, after here, we don't mention our face condition. That's why it's going up again, means it's completed the track. Okay, because we create here only here condition. Okay, so now what we are going to do, we need to add simply a condition, all the others condition. Okay, so if direction is right, right px is not is equal to 255, then again here also we need to say if a is greater than 5, then it will be stop and it will wait for our face points. Okay, here also if the direction is down, then again it's go right, so we need to simply say our face right condition if a is greater than 5. And here what we are going to do, here we are going to basically go left side. Okay, so anti-clockwise. So simply here we are going to say, we are going to remove up px, and we are going to say we need to basically go at the left side. So we are going to say the face at the left. So a is less than 5, then it will move at the left. That's it. We mention all the conditions clear. So simply if I save the code, if I run the code, now we will see the magic, friends. Okay, we are going to see all the action, and here it's stop. As you can see, it's go again, it's down again. Now this time I need to go left, so it's left, and it's going up. Here we need to go at the right, so right, it's going again, my face. Okay, again right side. Now this time we need to go left, so just make your face as the left, and then it will go up. Okay, so this is how, friends, you can create the self-driving virtual car with the help of pygame. And for more fun, you can simply add the real-time face tracking points. I hope you will learn something from this video. We'll meet our next video. Till then, thank you, take care, and bye bye.